Okay, friends, here is another classic problem that may or may not be on the test. It says a ball is thrown upward from the top of a cliff that is 144 feet high. So we can start drawing what's going on. Before we have a graph, let's just do a drawing. So here's our cliff. It's 144 feet high. And we are throwing this ball upward. The ball's initial velocity is 24 feet per second. Okay, so the ball is going to be thrown upward. It's going to trace some kind of arc, and eventually will hit the floor. So this trajectory that it's going to follow is going to be a parabolic, right? Trajectory, a parabola. The ball's initial velocity is 24 feet per second. The ball's height in feet is given by s of t equals that. So this parabola that we've drawn is actually s. It's that function. The other side is over here, but that's kind of before we threw the ball. This right side is after we threw the ball. So this actually kind of doesn't really exist. And now that we have this, if we like, we can impose some axes. So now we can think of this as the graph. So the ground is going to be, right, the line y equals 0. This is a height of 0. So down here, this point has coordinates, well, some special time value that we don't know yet, and 0, such that s of t star equals 0, right? We also know the coordinates of this point. That's going to be 0 time has passed because I'm holding the ball, and then the initial height, 144. This other x-intercept over here is going to be my other root. Okay, the question is, what is the velocity of the ball when it hits the ground? Over here. What is the velocity when the ball hits the ground? That means when the ball's height s is 0, that is when s of t equals 0. Okay, so I'm interested in the velocity. Great. So first, I need to figure out an equation, right? We need to figure out our formula for the velocity. So I know that the derivative of position is velocity. And so I can use my limit definition and eventually get to a point where I have calculated the velocity to be this. Just kind of skipping some steps there, because depending on when you watch this video, you will either use the definition or what we will call the power rule, which is kind of coming up later. But however we get there, we're going to get to this expression, this function for velocity. So this is my velocity function. Awesome. Now all I have to do is figure out, okay, what is this value, and plug it in right here. So to do that, we need to go back to the position function. And I'm curious about when s of t equals 0, what is that special t value? So we have s of t equals 0. Okay, very nice. So first things first, we can divide, we're trying to get t by itself. So let's divide by the least common multiple of these numbers on the right. My mental math is not so great at this time of the day. So let's use a calculator right here. Let's see, 144 divided by 8, 18. Awesome. So we've got 0 equals 18 plus 3t minus t squared. That we got by dividing both sides by 8. Okay. Now we can also divide by -1 to make things a little bit easier for our factoring. So we get -18 minus 3t plus t squared. I'm just going to rewrite that with my t squared out front, kind of in standard form. So now I need two numbers that multiply to -18, which add to -3. So what are those? That's going to be -6 and 3. So we've got t minus 6 and t plus 3. We can just check this real quick. So we get t squared plus 3t minus 6t, and on the outside minus 18. This is going to be minus 3t. T squared minus 3t minus 18. T squared minus 3t minus... Awesome, we got it. Okay, so this tells me that for the right-hand side to equal 0, either t is 6 or t is -3. So if we go back to our picture, our graph, maybe I can relabel this, right? Like instead of having the x-axis, this is our t-axis, this is the time axis. So we said 6 or -3, right? So right here, this is -3. That's my first x-intercept. And this one is when t equals 6. So we know that special time value that produces s of t star equals 0, right? This is the time at which the ball hits the ground. This is the time at which ball hits the ground. So now we can put this guy into my velocity function. So v of 6 is 24 minus 16 t. I'm going to show you a little trick for this multiplication here. So 16 is 10 and 6. 10 times 6 is 60. 6 times 6 is 36. So we get 60 plus 36 is 96. Awesome. So we have 24 minus 96. The difference there is what? 72? -72? Let's check. I'm tired, y'all. Gotta get this calculator. So we've got 24 minus 96. Yeah. So we've got -72. So it says, what is the velocity in feet per second, right? -72 feet per second. And the fact that it's negative makes sense because the position is decreasing. We are going downward. The position of the ball is decreasing. Okay, like I said, this is a problem that may or may not be on the test.